My name is Frank Mashraki. I'm VP of Technology. There, is that good? I'm VP of Technology for NetEdge. We are a graph analytics company, so everything we do revolves around graphs, and I'm an advisor to a couple of startups as well. And so I'm going to just go through, because we have a lot of want to cover in the next 20 minutes, but the basis of this, best I/O is no I/O for me at least, is in most of my interviews related to DBAs or sysadmins, eventually question would come up. I would ask them, so if someone asks you what's the best I/O, what's the answer you would give? And just for giggles, I'll let them know that if they answered correctly, the chances of them actually getting hired would shot up significantly. And that's actually one of the answers I got from one of the senior MySQL DBA position candidate. And of course, that was I was like, okay, I don't think we are talking about the same I/O. And of course, you guys probably know much more that keyboard is not the best I/O. But before I want to get started, I just wanted to say that how many of you are familiar with CAP theorem? Cool, excellent. So basically, you can either choose between, you can pick two of these for a shared data system that you want to be able to scale. You can't have all three of them. And because the talk is focused on I/O, a lot of times the question comes up about consistency, and you would be surprised that most large-scale systems actually let go of consistency, just so they can have availability and scalability, so they can achieve, especially for Web 2.0 companies. Partition tolerance you would choose for a high traffic website. Availability you want to choose for something that should be highly available. And consistency if you really don't care about the other two. So when the growth starts happening, this is actually one of my companies I worked for. And so the challenge we had was go from, take our infrastructure from 30 million page views a month to 150 million page views, and do that without going through a significant CapEx or without even doing major application changes, because we just need that over a very small period of time, and do that as soon as possible. Typical for all the Web 2.0 companies where you've already gone through funding, you can't raise more money. So as the growth starts happening, of course you start happening, a lot of things that you have to measure. And things can, kind of get quite lost in that, because effectively what's happening is that you're focusing on all this, but ultimately, in my experience, most of the time the issue would end up coming to be something that's I/O related. So can you really have no I/O? No, right? You gotta have some I/O, and I/O is gonna happen everywhere. I/O is gonna happen in, network I/O, memory I/O, disk I/O. Wherever you're doing, there's some kind of I/O happening. And so that then leads to the question, what would be the best I/O? So the best I/O in this, for a scalable system would be really in, efficient I/O, low latency one, the one where you are doing minimal I/O, you can distribute it, and hopefully all the I/O is non-blocking. And of course, at the end, you want to have as much sequential I/O as possible, not the random I/O. And for distributed computing infrastructures like Hadoop, etc., another important thing comes up being the locality. So having local I/O is a lot more feasible than, for instance, running it over a network. But again, for instance, Amazon's Elastic MapReduce, even though you let go of local I/O, the benefit you do achieve is the ability to dynamically scale your Hadoop cluster, for instance, being able to go from 100 nodes today to 500 tomorrow without having to do major changes. So when we talk about distribution of I/O, this is really not the ideal distribution, right? This is actually from one of my clients as well. And you can see the distribution scheme they chose ended up being quite different. And most people ended up choosing usernames that would start with M. So as you can imagine, the I/O load on those boxes was a lot more than, as you can see on the numerical ones. This is the kind of somewhat an I/O pyramid that I like to use. Basically, the green part you should use as much as possible in your application, wherever you can squeeze it in, wherever you can, and red ones you really should avoid. As you move up, you want to avoid those things as much as possible. And if for database operations, specifically for MySQL, this would be the same representation where you really want to avoid, for instance, replace, because replace actually is a delete followed by an insert. So you're doing two very expensive operations. And of course, insert here is assumed to be sequential, not like going everywhere. And then if you have a large application, like really data-intensive application, for instance, most of the work we do is related to matrix analysis of really large graphs. And our consideration really always is that to design applications that are write-once applications. So basically, we try to avoid, wherever possible, updates, deletes happening on live data sets, and just structuring an application in a way that your main production tables at any given point are mostly involved in selects or inserts. There's a lot of benefit to that because delete is a lot more expensive than select or insert. So quick question, is it okay if to waste disk space if it would result in really efficient I/O? That was the situation I was in when the challenge I talked about earlier, going from 30 million page views to 150 million without significant capex or anything or major application changes. The thing that was, the only thing I could come across was okay, we seem to have a lot of disk. Can we use that, utilize that in order to lay out data on disk in a way that is a lot more efficient? Because re-architecting our sharding subsystems, our partitioning systems to be able to take advantage of the growth that we are about to experience wouldn't be the best, situation. So I did a lot of research on this, and throughout my network, which consists of really amazing people, the answer I got was no, you shouldn't go for bloated primary keys or stuff like that because it's going to come back to bite you. But in our particular case, what was happening was we had a table with auto-increment auto-increment column, and for auto-incremented columns, you can expect a table lock for each insert, causing contention. So whenever we would have selects running, all the black arrows under thread concurrency represent actual InnoDB threads that are running. So whenever we have all the selects coming in, everything would be fine. And then the moment we have some inserts coming in, now table locking requests are competing with the select requests that are going on. And before we know it, this becomes the problem where all the currently executing threads are taken by, are waiting for basically a table lock acquisition. And all the selects and more inserts are piling up, really bringing down the system. So for us, when we further looked into it, we found that, okay, what's happening really is that in order to generate a subset of a page, what we are doing is we're looking at different, sectors of the disk. So in order to generate one given page, we might have to do 30 to 50 disk seeks in order to get to really complete, satisfy that one query. So what we started doing was using the clustered index approach. We tried to change the primary key, unique keys, etc. And what we try to do is make sure that the data, the clustering indexes we choose are the ones based on which we are querying it most of the time. And what that did was that it consolidated most of our data set for that particular query into as few data pages as possible. And of course, that means that you would be doing a lot less seeks in order to satisfy the same query, and suddenly your capacity really kind of increases. And all this is really back-end change, nothing to do with the front end. So in our cases, our developers just were aware that the change has been applied. So this is the effect of the. By the way, the key that we did choose was a really bloated one where it consisted of 3 columns. The first one was basically the foreign key to which all the elements would belong. The second one was the timestamp based on which we were sorting. And by choosing that as a second column, we assumed that the data on the disk would already be sorted in the way that you want to retrieve. So you can basically let go of the sort by order by clause. So you can see that the pink line is the one with the bloated key, and the overall, on the x-axis, you are seeing the number of seconds passed for the same test load with both the schemas. And you can see like how little I/O was generated with the pink, with the new composite clustered key. The benefit of all this is, of course, if your disk is free, then guess what? Your inserts can happen faster. Table lock requests can be fulfilled faster. Basically, you're not keeping your disk at 90% utilization consistently. You're using it, but when you're using it very efficiently. Another benefit, of course, is that because, for instance, in this slide, right? If this, the data pages that I tried to represent, if these data pages are loaded in memory, guess what? You're not really using your memory I/O in an optimal manner either, because what you're doing is you're scanning pages in memory, but then you're only reading chunks of those data pages. And so it's really like a waste of, resources there. But however, in this example, what's happening is that all the data pages that you are reading in memory are more likely to contain a majority % of your working data set, therefore satisfying your queries in least amount of requests possible. This is another graph for the same analysis. You can see that the disk busy percentage for the pink, for the new composite key ended up being considerably less than what was already. So if disks are free, you can squeeze a lot more performance through that. And this is about the actual data that was read in order to satisfy the same test. Again, you can see that not only the pink was substantially less towards the end of the graph, but also what happens is that the test for the bloated primary key ended up finishing significantly before the test with the with what we had. I have 8 minutes, so I'm going to quickly go and, some of these details I put, I'll put the slides out, and you're more than welcome to contact me with any questions, etc. But, another thing that we found out that, okay, in addition to doing this, what we resorted to was implementing a series of caching strategies, and I've just included a couple of them here. For instance, this is the classic one, non-deterministic cache, check database, check memcache, check database, populate the, I like to hit that. Anyway, so then the other thing you can do is we were deploying an IAM system, and one of the most taxing thing there was for us was really this keeping the state of all the users that are involved. And what we ended up doing was basically maintain a state cache, deploy a different memcache cluster. Then for deterministic cache, this was, a lot of people don't really like it, but in our case, it really went through. What we did was when our site would when we would I like to say startup, but people get confused. But after a maintenance period, when we want to warm our databases, what we would do is we will load all the data and maintain memcache on persistent storage as if it's a persistent cluster. And so, we will assume the benefit of that was that we were able to outsource a lot of user operations to memcache instead of hitting the database. And a lot of NFS, if you're using in your system, you will find that there's a lot of file system overhead cache, a file system cache overhead involved. So what we also did was we let go of the NFS file system cache, and we instead put memcache in front of it. And then images, everything in our case was going into memcache. Again, if you have web services, you can really cut a lot of I/O by implementing caching in 4 points at the client level, proxy level, endpoint, and service level. Of course, you don't need to cache everything, because if you are caching and not really utilizing the cache, that's a lot of times that's more expensive than not caching it at all. So a typical example that I run into every now and then is MySQL query cache. A lot of people, you can easily get 10 to 15% performance improvement based on how much contention existed and for query cache lock contention. Really, basically, you should be, if you use Explain, you should really be writing your own queries, not using frameworks to decide what query should run, because a lot of time they'll come back to haunt you. If possible, definitely, you should use covering indexes. The amount of I/O that generates compared to a full-blown query execution is significantly less. So you can, again, you can satisfy your queries just by indexes, not having to hit the disk. Clustered indexes, again, I showed earlier how it can benefit, and of course, for sure, avoid all duplicate indexes. The other way, surprising way to cut a lot of I/O requests, and you'll be surprised how much difference this really makes on large data sets, especially where you have 200 to 300 million records in a table or more, is to choosing the right data structures, right? So, for instance, like a lot of people know that varchar is a lot cheaper for disk storage, but people are sometimes surprised that it's not so cheaper when it's loaded in memory, so you're wasting a lot of memory with varchars. The other thing is int versus big int. If you really don't need big int, no need to go for that. Date time, timestamp, again, 8 bytes for date time versus 4 bytes for timestamp. And all this can add up, especially if you have multiple indexes defined on the same columns. And here I put some of the things that you should totally investigate if you're using MySQL on your DB. Basically, it has a bunch of I/O optimizations in there. Do not ever use the last option unless you really hate your job or hate your employer. We have had a massive, pretty good, interesting disaster at one of my employees because someone had put this in there. Apparently, after this, a small power surge can really corrupt your databases, just so you know. I had these three for about, actually I have 3-4 minutes I can go with. So another cause of, people don't think about this in terms of I/O per se, but a lot of times, for instance, we were using C3PO at one of our clients, and what we found out that the connection pool was database specific, not server specific. So if you have 2 databases residing on the same database, then the number of connections, the connections open, especially the minimum ones, cannot be reused. So if another connection would come, even though it's going to the same connection, it won't really let it go through. So of course, in that case, you can take off contention by simply creating a connection pool that really is server-specific, not database-specific. So there are a lot of tools available. The best thing I recommend is choosing the tool that does the job you want to do with the least amount of I/O. Recently, we had to design an algorithm for graph calculations, and we designed one algorithm in, just for conceptual sake in MySQL. Of course, that was just so we can actually wrap our head around it. But after that, what we did was we deployed 3 versions in HBase. None of them was efficient enough. Then finally, we just implemented a 5th version, which is an actual MapReduce, doesn't take advantage of HBase or anything like that to serve. But there are a lot of various options. You'll be surprised how different I/O, load would be if you were using different products. And Tokyo Cabinet, for instance, is gaining a lot of momentum, etc., in this space. So. This is the way to contact me. Feel free to, follow me on Twitter, and then I can stalk you back. And you can, email me with any questions or grab me around if you have any, questions. Thank you very much. I don't think we have time for questions, but, you can totally stop me. So, thank you.